For the unit on transformations, you're going to need a ruler, a pencil. If you like to differentiate between the things that you're doing, colored pencils are helpful, and 5 sheets of paddy paper. If you don't have paddy paper, parchment paper or tracing paper will do just fine. Take 1 sheet of paddy paper and fold it in half, and with your ruler, draw a line over the. Now on one side of the fold line, draw a very simple non-symmetrical figure. So the one I'm going to show you is a picture of one of my cats. Keep it very simple. You do not need it to have any fancy details. We're going to perform a reflection by folding over the fold line or the line of reflection and tracing through the paddy paper, trace the exact image that is on the other side. When you have completed the tracing, what do you notice when you open the paddy paper up? In my case, I expect to see 2 cats looking at each other as if they were looking at their image in the mirror. So I hope you have something like that. I now would like you to take your ruler and a colored pencil or your regular pencil, select at least 4 corresponding points and draw a line segment connecting those points. So for instance, in my case, I will take the tips of the tails. I will take maybe the tips of the ear that is closest to my line of reflection, and I may take 1 or 2 of the feet, but being very careful to select the one that corresponds to the other. And you can check which one that is by marking the one you wish to choose and folding and checking. So what I'm looking for is that these connecting segments become the structure behind a reflection. And I would like you to write 2 key points that you notice about those connecting segments. Go ahead and post those on the discussion board. Take a moment to post your properties, and then we will move on to the next part of the activity. Here I am demonstrating the 4 connecting lines. And here I have placed some very formal markings on my figure to demonstrate some of the properties that I determined on those particular lines. Notice that the tick marks and the arrows and the little boxes are formal language that we use in geometry, and this is the stuff of the Van Healy descriptive level, the second level analysis level that he talks about, where formal language is introduced. So now we have a way to define what is behind a reflection. So we're less concerned about looking at the original figures and much more concerned about the lines that demonstrate that it is in fact a reflection. I am now going to ask you to perform some additional reflection activities, and I'm not necessarily going to provide you with the answers, but I will add some additional discussion threads where I want you to do some similar things and then add your thoughts about the properties behind those transformations. For the next activity, with a new sheet of paddy paper, I want you to draw a pair of parallel lines. In this case, I have actually used the sides of the ruler to draw them because I do not expect any kind of formal construction at this point. I will ask you to draw a figure on one side of the 2 parallel lines and be able to reflect it across the first line and then across the second parallel line. If you wish, you may do what I have done and draw your asymmetric figure in between the lines, because I know that if I reflect this figure to the left, it would be the same as if I had drawn it on the left and then reflected it into the middle. And then I want you to reflect the middle figure across the right-hand line. Again, I will ask you to draw at least 3 lines connecting corresponding points on your three figures and describe what happens and put them into the appropriate discussion thread on translations. Now, for the third transformation, I want you to fold the patty paper in half, just like we did for the very first one. And then I want you to make a second fold, this time across the first fold, forming a right angle in the middle of the first fold. You got that? So when you open your patty paper up, you have four areas divided up into by four right angles, okay? So in one of the four areas, I want you to draw an asymmetric figure. I want you to fold across the first fold line and trace the reflection. And then I want you to open it up and fold across the second fold line and trace the reflection of the first reflection, so that you have your initial image followed by two reflections. That means that one of the spaces does not have a tracing in it, and I want you to leave it that way. So this time I want you to draw your connecting points from the very first figure to the third one, that is to the second reflection, and tell me what happens. So we will now have performed the three most important transformations that learners in elementary grades have to perform. I am going to give you one more, but I want you to make sure that you understand the properties behind all three of these. Once you are happy with what you have put into the discussion forum, please go ahead and download the transformations activities from the Blackboard course resources. I would like you to do these activities and upload them as PDFs, please, into the assignment transformations. There will be a bonus activity to follow this particular slide. This will be a bonus to follow the other three activities from the course pack. This time I would like you to take your patty paper and draw two intersecting lines that do not intersect at right angles. So make an acute angle fold, that would be fine. Fold across both of these lines. This time I would like you to draw your asymmetric figure in between the two lines that make an acute angle. Got that? So using the smaller space. Reflect over one of your fold lines into one of the obtuse spaces, and then reflect the original figure across the other line into the other obtuse space. And again, make these connections and see if you can figure out how the two reflected figures relate to one another in relation to the angle between the two reflection lines. And I will put this up as a bonus discussion thread.